Good day, Doctor. Today, me and my group members, Alya, Nasuha, and Fei Zhi, are going to present our group project part 2 about Mongodb. In this project, we are trying to execute what we did in the first part of the project in SQL in a NoSQL database. In question 1, we try to convert the RDBMS into a NoSQL database. Project 1, the RDBMS with the following schema as shown in the ER diagram below is used. We have this bank information with client information, account information, their district location, their card, transactions, order, loans, and disposition table. All of these separate discrete tables, we are trying to join them into new NoSQL database. As you can see from the ER diagram above, there is a total of 8 tables. For project 2, we are converting the tables into documents in embedded form to fit into the document type NoSQL database structure. The foundational logic of NoSQL database building is inherently distinct from that of SQL database. For a relational database built by SQL, one of the signature functions is that it uses the join function, which allows all these atomic tables to be threaded together and form complex databases. While it is incredibly powerful, it does not facilitate horizontal scaling as the complex relations impede data sharding and replication required. With its flexible schema, NoSQL database structure tackles the issue with the use of embedded documents to minimize the amount of relations between collections. Thus, in this project, we try to integrate and embed as much information as possible in a single document. However, embedding all tables within a single document is definitely impractical, as there are an enormous amount of combinations that we can adopt to build our NoSQL database. The rule of thumb is to design the database based on our goal. Therefore, the database is reverse engineered by referring to our desired output in the queries. As a result, 3 collections are derived from the 8 tables here. For instance, account info.json, account statement, and account client info. They are derived from the tables, from the original tables, with aggregate queries like lookup and unwind to join the tables in a single document, and project to reshape the document into our desired schema, and out to export and aggregate results as new collections. Below are the examples of 3 collections derived. Firstly, we have our account info.json. In this account info, we join the tables of account, district, loan, and disposition. The example is as shown below. We can see that we have our account ID, issuance frequency, date, and the district, which is the subdocument, and the client ID. The embedded document is derived from aggregate pipeline as shown below. We used a lot of lookup and unwind to join these different tables, and then we use project to shape our collections to a desired ones. And then finally use out to export our aggregation result into a new collection. As for the second collection, we have our account statement.json. This is slightly different as it focuses more on the transactions and orders, while it still consists of account information like account ID and issuance frequency, but it is just to set a context where we can have our bank order to and transactions attached to. This embedded document is derived with aggregation pipeline as shown below. Project first to extract the desired information from our account collection. And then we have a lookup to join transactions and orders table. Finally, we use out again to export into another new collections of account statements. Finally, we have our client info.json, which is a combination of client, district, account, disposition, card, and loan to form a comprehensive picture of the client. The example as shown below, we have our client ID, gender, birth date, his locational data, his district, and also the account data, his or her account. So the embedded document is derived with the aggregation pipeline as shown below. This is a whole lot of lookup and unwind, and then after that also project and out with the similar logic with collections above. And now we'll move to the second question, where we present in our MongoDB canvas. I'll pass the baton to our team member, Fei Zhi. Thank you.
So for the question 2, will consist of 10 main questions. So let's get started with the question 1. For the question 1, we'll find the distribution of male and female clients that we use group functions to group by the gender. Then we also calculate the number of the clients by the gender. So using count and sum. So for question 2, that we want to find the distribution of clients by age. So yeah, open the pipeline. Scroll, okay. So we use add fields function to calculate the age and add age as a new field. After that, we group the clients by age. Then we project the fields that we want, and also we use switch case to know the age range of each client. And the last one, we calculate for the sum of the clients, means that we calculate for how many clients that under those age group. So for question number 3, we want to find the distribution of clients by the district. A descending order means that we want to group by the district, the clients who have the most loan. So for the first, we group by district ID. After that, we sort it, means sort it to descending order. And the last, we project the district details that we want to display. So we can know that the highest amount of the clients by group by district. So for the number 4, we want to know which there are a few things that we want to find out. So we want to know which age group and gender has the highest total loan number. And for the B, we just group by age, and for 4C, we just want to know only by gender. So let's start with A. So for first one, we use add fields to add the birth date, means we calculate for the age. Can you scroll? Yeah. So we calculate for the age, then we group by age group. Then we project it to display the client info. Then in this project, we also group by we also group using switch case to group by age range. So next. So at here, we calculate for the loan amount using sum and also average. Average is for mean loan amount. And after that, we sort it by the highest total loan amount. So in this question that we know which age group and also gender, age group and gender have the highest loan amount. So same goes to B and C. B is just grouped by age, and also C just grouped by gender. So I think, Alya, maybe we can proceed with next question.
Number 5, is it?
Number 5.
Okay, so for number 5, we are trying to find the amount of loans for each different district. For A, we find out the amount of loans for district with highest total amount, so that we can make more money out of them. And Can we get to the part? All right. So for this one, the pipeline is relatively simple. We first use a group to group by district ID, and we find out, we sum the total loan amount for each district. And then after that, we also find out the mean loan amount from each district. After that, we use a sort pipeline to sort this whole collections by mean loan amount in descending order. And then after that, we make use of project to extract the district ID from the ID collections, from the ID object. For 5B, it is relatively, it's also quite similar to 5A, and then the amount of loans are the lowest total amount of loan. So for this one, the logic is identical with the last question. Right? Just that we have changed the sort from descending order to an ascending order one. Right? Yeah. And then we can proceed to question 6. Right. So for question 6, we want to know, do people from places with higher or lower salaries tend to borrow more? In this one, we first have to use an add field function to change the average salary in each district to integer instead of string. After that, we use bucket to group this average salary range into several buckets. We have 7,000, 8,000, 9,000, and then up to 13,000. And these boundaries are the lower boundary of each salary range. And then from this stage, we get the output of mean loan, which we have the average of the loan amount, and the mean salary, at which we get the average salary of each district. So after that, we project to find out, we use project to extract the information we want. That is the salary group lower bound, and then the mean loan and the mean salary. So from here, we can find out which district has the mean salary and mean loan for each district, and determine which one has a higher amount of loan. Yeah.
Okay, and then we'll proceed to number 7, where number 7, we want to find the credit transaction for each client who own the gold type. So the pipeline will look like this. So firstly, we will join the table of account statement. We use lookup, and then we unwind the table into the new name transaction. And then I use unwind account ID to make it into a single document. And also I use unwind for transaction to make it into a single document where the transaction will become like this instead of in array. So I use match to match the transaction to find the credit card type, the transaction type which is credit, and then I use match to find the credit card type, gold credit card type. And then I use project to project what I want to find in this question. So in project, I will use client ID, card type, account, and transaction amount to see each of the account ID belongs to which card type, and then which transaction amount. So and then I will use group to group the total transaction amount into an client ID, account ID, and card type. So the output will look like this. So client ID 365 belongs to account 270, which is gold type, credit card type, and the total transaction is as below. And then we'll use project to make it into a single output like this instead of in ID. And then I sort it in ascending order, but by client ID. And then move to number 8, which I want to detect the potential gold card holder. So in this pipeline, alright. So in this pipeline, the flow is just the same with number 7, which I use lookup to join the table account statement and then unwind the transactions, the new names of the from the lookup, and then I unwind the account ID to make it into a single document instead of an array. Or same goes with transaction, and then I match the transaction type into credit, and then I try to unwind the credit card type, which I want to make it into a single document also. And then use project to project the output that the desired output that I want for this question. And then as you can see here, the client ID 9, which is gold type card, and the transaction. And then for next is I group each account to find the total transaction for the desired account ID lah. And then for the project, I make it into a single output instead of in ID, and then I sort it by account ID. So as you can see, the output is account ID 7 with the gold type user, with total transaction is 623,775, and goes to other output. And then for number 9, is I want to find the client profiling for client who use credit card. So I group it by gender. So the flow is just the same with number 7 and 8. I use lookup to join the table account statement and then match the transaction type into credit, and then I unwind the gender. And then I project it into the desired output that I want. And then after that, I group it by gender, card type. So gender male with card type gold, the total will be 5959797. And same goes to other output. And then I project it, I make it into a single output instead of in ID. And then next is number 9C, same, just same with number 9, I group it by gender. So on number 9C, I group it by district. The flow is just the same, but on the project, at the end of the aggregation, I use project to I use group to group it by district ID and card type to find the total transaction by district and card type. So the output will become like this: the district 73, card type classic, the total transaction is 3038638. And then I sort it by ascending order. The district ID, I sort it by ascending order. And then number 10, I will pass to Fei Zhi.
So for number 10, we want to find the inactive users. So first of all, I use project to select some details that I want to extract and display. After that, I unwind it as unwind the transaction details. Then I use add fields to calculate for the how long of I use add fields to add for the convert the string to that functions for the that. After that, I use add fields to get to calculate for the debt difference for the latest transaction debt that I deduct with the last end debt, means 1999 January 1st. So I deduct it, and after that I will get the day difference. So if day difference is more than 365, it means that it is counted as inactive users. So just see the results. So at here we can list out who are those inactive users. So I think that's all for question 2. Then I will pass to Xian to explain on question 3.
For question 3, we are basically asking, is NoSQL better or SQL better after using this for the same project? You can say that it depends, right? Because while NoSQL database has a great advantage in schema flexibility and scalability, it also comes with its drawback. For example, it has very low flexibility in queries. As the query patterns of NoSQL database is very much predetermined by its database design, it is not as flexible as SQL that can be used to explore patterns and relationships freely with the join functions. While there is a lookup available, it has significantly lower performance compared to that of SQLs, while also being more brittle. In the case of project 2, we can see that the size of data is still relatively small, thus there's no scaling problem required to be considered here, as the goal of our query is to find out our clients' behaviors and patterns to improve service and marketing. It is important to retain the ability of flexible query provided by SQL to allow for more comprehensive analysis instead of iterating of well-understood parameters that NoSQL might result to, which also will cause the confirmation bias. So in this project, SQL is preferred over NoSQL. And that's it for our presentation. Thank you for listening.